Okay, hello everyone. Today we're looking at permutations. We've already looked at them a little bit. I just want to define exactly what they are. That's our objective for today, to define and count permutations. Our essential question is, how do we count the number of possible arrangement subsets? All right, how do we arrange some numbers from a set of numbers? And just to review, factorial we looked at yesterday. Like 4 factorial is 4 with an exclamation point, and that's shorthand for what it means is 4 times 3 times 2 times 1. All right, it's a product sequence of successive decreasing whole numbers. All right, again, 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, 1 factorial is 1, and 0 factorial is also 1. All right, we looked at this example already. I just want to review it. If we're running a race with 6 runners, how many different arrangements are there for the runners to finish first, second, or third? Again, 6 runners can finish first, 5 runners can finish second, and 4 runners can finish third. All right, so 6 times 5 times 4. There's 120 possible ways that we can arrange 6 runners first, second, or third. And we're arranging 3 from 6. Picking from 6, arrange 3 of them. How many different ways can we do that? All right, this is known as a permutation, and this is how we write it. Okay, it's just a big P. The total number of objects that we're selecting from is the n. That's the larger number. And then a subset of that number, the r, is what we're arranging. And we're arranging r from a set of n numbers. All right, as an example here, 6p3. That means from 6, arrange 3. How many ways can we do it? Well, again, it's 6 factorial divided by 6 minus 3 factorial. All right, well, that's 3 factorial. So 3 times 2 times 1 is the bottom. And the top is 6 times 5 times 4 times 3 times 2 times 1. Again, the 3 times 2 times 1 cancels out, so we end up with 120. Again, I want you to look at this 6p3. You can think of it like this. Starting with 6, what are the first 3 numbers in the product sequence of your factorial? The first 3 numbers will be 6, 5, and 4. All right, you can think of it like that. In a permutation, the definition, it's an arrangement of some or all objects of a set in a specific order. All right, the formula is right here. Again, r has to be less than n, but greater than 0. And again, r is a subset of n. R is less than n. Right? R is how many we're arranging. N is how many we're picking from. All right, in a permutation, very important, order does matter. Order does matter in a permutation. All right, it's a lineup. Okay, it's an arrangement. All right, example 1. How many 3-digit numbers can we write using the digits 1 through 5? Again, that's from 5, arrange 3. 5p3. You can put it in your calculator if you want. Well, this is kind of a simple one. Again, 5 minus 3 on the bottom. It's not 3 factorial on the bottom. It's 2 factorial on the bottom. All right, so we end up with 5 times 4 times 3, which equals 60. Again, it's the first, go all the way back to the 5p3. Starting with 5, list the first 3 numbers of the sequence in the factorial. 5 times 4 times 3. That's the first 3 numbers in the sequence starting with 5. All right, that equals 60. All right, another example. How many different ways are there to choose a president and a vice president from a list of 8 candidates? Again, that's from 8, arrange 2. All right? Because one has to be the president and one has to be the vice president. All right? So the top is 8 factorial. The bottom is 8 minus 2 factorial. All right? So that's 6 factorial. So that gets rid of the 6, 5, 4, 3, and 2. On the top and the bottom, we're just left with 8 times 7. Again, if you can go all the way back to the very beginning, from 8, arrange 2. Just start with 8, and the first 2 numbers in this factorial sequence is 8 times 7. All right, this is examples of different permutations. Again, you can put these in a calculator and get the answer, and we'll talk about that in class. All right. From 7, arrange 4 would be 7 times 6 times 5 times 4. Now, just to show you a couple things. From 4, arrange 4. In other words, 4p4. All right, that equals 4 factorial. That equals 24. That's the same thing as 4 factorial. All right. Now, from 4, arrange once. Arrange once. We can only do it one time. All right, for each different. All right, sorry about that. Guys, again, this example right here. All right. From 4, arrange 1. All right. We can pick each one 4 times. So that answer is 4. There's only 4 different arrangements of 1. All right. I also want to show you that from 4, arrange 3. There's 24 ways to do that. It's the same as from 4, arrange 4. There's 24 ways to do that too. All right, I want to show you guys that. It's just as if we took 1 out each time from this 24 right here. We just took 1 out each time, so it's still 24 ways of doing it. All right, guys, please complete the homework assignment in the purple folder. And thanks for listening.